Okay, in this video, we're going to go over a warm-up for 2.6 economic order quantity. So this is the day 1 material. So here's the warm-up. It says, suppose R&B Beverage Company has a soft drink production that has a constant annual demand of 3,600 cases. So this constant annual demand, that's the quantity they're going to sell every year. Okay, constant annual demand. So that means that demand, that quantity, has to be met by R times X. Okay, and that's going to be our constraint. So let's think about that for a second. Do not introduce another variable. I don't need the variable Q. I just wrote that so that you understood what I'm going to be doing next. So the quantity that they need to sell is 3600. And that's comprised of R, which is number of orders placed a year, and X, number of cases of soft drink in the order. Okay, so R is orders, X is cases. This is my constraint. If I can get this to right. Okay, hold on. So that's going to be my constraint. Okay, let's try this again. Okay, so this is going to be the constraint. All my little pens are not working. Okay, so apologize for that delay. That is the constraint. Remember, we're going to have an objective function, and for an economic order quantity in objective function, we're going to say that inventory costs are going to consist of ordering costs plus carrying costs. So I'll discuss this more as I go through this problem. All right, the ordering costs are $20 per order. So here comes ordering costs. And if it's $20 for every order I place, and the order is R. All right, that's done. Okay, then we go on. So here was the ordering costs. Okay, then it says, and inventory carrying costs are $28.80 per case based on total inventory. So that means that you do not divide by 2. They're going to charge you on your total inventory. So that means your costs are going to be plus 28.8 times the number of cases you order each time. So that's your X. All right, so be certain you understand carrying costs, because that's where people usually make their mistakes. If it says total inventory, you are not going to divide by 2. That would be average. Okay, when you divide by 2, you take the average of the high, which would be, in this case, whatever the X happens to be, and then the low would be 0 because you sell everything out. So this is not average, this is total. All right, now what I'm noticing is I have 2 variables. One is an R and one is an X, and that's a crazy looking 8. I'm going to fix that. Okay, so I have to use my constraint to switch one of them out. So what if I switch out my R? All right, if I switch out my R and have everything in terms of X, this is what I would get. 20. Now how am I going to switch it out? I'm going to use my constraint just like I always do. So R equals times 3600 divided by X. Make sure you know how I got that. And then plus 28.8 times X, and there's a little decimal point right there. All right, so clean this up a little bit. 20 times 3600 is 72,000. Bring the X up, that's X to the negative 1, plus 28.8 times X. Okay, I'm going to just erase the problem for a second. They want to know what the EOQ is. So let me get rid of this so I have a place to write. All right, so They want to know what the EOQ is, economic order quantity. That's both the R and the X. So I need to figure out where that inventory costs are going to be the lowest. So if it's low, it's going to look like this. I want to know where that slope is 0, so find the slope. IC prime equals, taking the first derivative, I get negative 72,000, and then that's going to be x to the negative 2 plus 28.8. Okay, the x drops out. So set this equal to 0, and when you do that, when you set the first derivative of the inventory cost equal to 0, I am looking for this critical value right here, the bottom of the curve. Okay, so I get 72,000. I'm going to move my x to the denominator, and that makes the exponent positive. That's going to equal 28.8. So what you're going to do now is you can multiply, cross multiply. So 28.8 times x squared gives me 28.8 x squared equals 72,000. Make sure you have all three zeros. Divide both sides by 25 by what? By 28.8, and you end up getting x squared equals 2500. Take the square root, you would get plus and minus 50, but because you cannot order negative 50 cases, 50 is what I want. That is only half of my economic order quantity. So far, we'll put it in a red box, so far I have x of 50. How do I get my R back? The way you get your R, and x's in cases, is to plug it back in your constraint, just like we always would do in previous examples in other sections when we were optimizing. So if I'm going to plug it back in, I'm going to say, I'm running out of room, so I'm just going to state it, 3600 equals R times x. Divide both sides by the x that you have, which is 50, and you should end up with R equals 72 orders. So you're placing 72 orders a year, and each order consists of 50 cases. So make sure that makes sense to you. Here are my two answers, and I'm going to go on the next page and do the reverse side of this warm-up, which is the ABC Company problem. In the second problem, it says the ABC Company purchases a component used in the manufacturing of automobile generators. All right, that's basically alternators. So ABC Company requires 12,150 cases of these components per year. There is my constraint. So your constraint is that the number sold per year has to equal 12,150. So that equals the number of orders placed a year by the number of cases in each order. That is your constraint. All right. The cost for placing an order is $10. All right, let's work on our inventory costs. Inventory costs equal the cost for placing an order, $10 times the number of orders, which is the R. And plus, the carrying cost for components is $30 per case. Okay, you've got to read the whole thing. Per case, computed on the average. There's that word. That's going to make me divide by 2. So $30 per case, so that would be times X, but it's based on the average, so divide your X by 2. Okay, that is your inventory cost. You can then rewrite it and make that 30 a 15 when you cancel with the 2. Okay, so why don't we go ahead and do that? You see that it was 30, so I'm going to go ahead and just to save space, I'm going to erase the 2, erase the 30, and make that a 15 because I divided the 30 by 2. Okay, so that's my objective function in two variables. So let me also erase the underline here for the x. All right, next thing. Let's go ahead and we need to figure out how I'm going to optimize this if I have two variables. So your normal answer is let's switch out one of the variables. So I'm going to replace the r. So what I'm seeing is that if I replace the r, I divide both of these sides in my constraint by x, and I get that r equals 12,150 divided by x. So let's write it in my constraint. Wherever I have an r, and I only have it one place, I have 12150 over x plus another 15x. Alright, so that's going to end up being 12150, another 0 from the 10 multiplication, x to the negative 1 plus 15x. Okay, now what I have to do is take the derivative. Okay, so each of these is just plain old IC. Now I'm going to put a line here, and I'm going to say IC prime equals. So taking that derivative, I get negative 121,500 x to the negative 2 plus 15. Set that equal to 0 because I want to know where the slope is 0. That will be the minimum cost, and that's what I want the x value for. Okay, so set these equal to 0, or equal to each other, the different components, and bring your x squared to the denominator following the exponent rules. That's going to equal 15. Now you should be able to solve for this at this point. I would say 15 times x squared equals 121,500. So divide 121,500 by 15 and take the square root of it, and I'll change color so you can see, and I end up getting x equals 90. If I take my 90 and plug it back up here into my constraint, I will get r equals 135. So you should be able to do these two problems. They are good examples of economic order cost. The first one was based on total inventory cost, and the second one's based on average inventory cost. Make sure you are very smooth with the setup and you know when and what to divide by 2.